Hello and welcome to another worked example problem with Dr. Schleif. This is question 30 from paper 13 that was administered in the October-November season 2016. The question reads, which path shows a possible movement of an electron in the electric field shown? There's a couple of key ideas that we want to be mindful of when we're looking at an electric field like this. They do not show us the polarity of the plates there, but they do show us the direction of the electric field and it's pointing down. So remember that the way the direction of an electric field is defined as the way that a positive test charge would move. And so if we put a proton, would be sort of the ideal test charge. If we put a proton in that field, it would have a force pushing it down. So an electron has the opposite charge of a proton, it's negatively charged, and so it's going to move in the path of either A or B, right? It's going to be deflected upwards. And this is why electricity is different than gravity. Gravity is always bringing everything sort of down. There is no repulsive sort of force there, but with charges, we can have that. So things can, fly up. We don't really see that happening with gravity, right? And then the question is just, would it be the path of A or B? And B just kind of looks like a little bit of a deflection. And then A is where it's, sort of more curved. And so we want to follow that parabolic trajectory. Choice A is correct here. The other way to sort of think about that is that an electron is very low in mass. The mass of an electron at rest is 9.11 by 10 to the negative 31 kilograms. So it doesn't have a lot of inertia. And so the moment that it enters that field, the force per charge, which is the strength of the field, the force is pushing that charge tremendously, right? So the electron doesn't have a lot of resistance to that force, to that change in motion. And so that's why the correct answer is A.